Oumuamua, which is an object that we detected in space that you believe could possibly have been extraterrestrial.
First time ever, an object from interstellar space has been observed to visit our solar system.
Ever wondered about mysterious signals from space? Well, the cosmic world just threw us a curveball, Oumuamua. It's not a planet or a star, but something mysterious that popped into our cosmic neighborhood in 2017. Joe Rogan recently delved into the bizarre reappearance of Oumuamua. He revealed how Oumuamua suddenly showed up again and is sending signals to Earth. Astronomers and scientists are abuzz, trying to figure out what this celestial wanderer is up to. What's so special about Oumuamua's return, and what could its signals mean for us here on Earth? Join us as we explore the latest developments surrounding Oumuamua's reappearance and its transmission of signals to Earth. The Puzzle of Oumuamua's Unconventional Journey. Understanding and categorizing objects in space usually follows a straightforward process thanks to our space knowledge and technology. However, Oumuamua's story is quite different. Oumuamua, a space object from deep interstellar space, has puzzled scientists and astronomers, earning its name meaning a messenger from afar arriving first. Objects from interstellar space occasionally enter our solar system, but Oumuamua's unexpected appearance left us baffled. What caught scientists' attention initially was its odd shape, resembling a sausage or hot dog. While asteroids typically have irregular shapes and orbit within our solar system, Oumuamua stood out with its distinct engineered appearance and its unconventional path around the sun. This uniqueness sparked controversy and curiosity, drawing the interest of Joe Rogan, who explored Oumuamua's mysteries in a podcast episode with Avi Loeb, a theoretical physicist. Despite Oumuamua's swift departure from our solar system, it has reappeared and is now transmitting signals to Earth. Rogan recently shared substantial information about this enigmatic object. Upon its arrival, Oumuamua challenged the norms of space travel. Unlike typical space objects that move at consistent speeds relative to celestial bodies, Oumuamua traveled at its own pace, initially prompting speculation that it might be a comet. Comets, icy bodies in space, develop tails due to vaporizing volatile materials when near the sun. Oumuamua's remarkable speed led to comet suspicions, but it lacked the characteristic tail. Some researchers theorized it could be expelling gas, propelling itself like a rocket. However, the absence of a visible tail, a crucial comet feature, posed a challenge to this theory. Had Oumuamua been a comet, its distinct features would have aligned with known comet traits, even as an interstellar object. Yet its unusual behavior continues to baffle scientists, raising more questions than answers. But how was this mysterious space object discovered? You see, in the year 2017, the field of astronomy experienced a groundbreaking moment with the identification of a celestial object named Oumuamua. This discovery stood out as an exceptional milestone in scientific exploration, creating waves in the realm of astronomy for a distinctive reason. Oumuamua represented the first ever observed interstellar object traversing through our solar system. The significance of this finding cannot be overstated. Before Oumuamua's detection, astronomers predominantly directed their observations and studies within the confines of our solar system. Even within this limited scope, numerous phenomena remained incompletely understood. However, the appearance of Oumuamua heralded an entirely new frontier of exploration, unlocking doors to an unprecedented opportunity for researchers to closely examine a celestial body originating from beyond our solar boundaries. The arrival of Oumuamua wasn't just a random event. It was a cosmic occurrence that offered an unprecedented glimpse into realms previously inaccessible for direct study. Picture the excitement this stirred among scientists whose main focus had been exploring the known celestial bodies within our solar neighborhood. Suddenly, they were faced with a mysterious visitor from the vast reaches of interstellar space. To call this discovery groundbreaking is an understatement. The study of Oumuamua held immense significance for several profound reasons. First and foremost, it provided scientists with a rare opportunity to explore the diversity and makeup of objects originating from distant star systems. This change was a key to unlocking deeper understandings of the fundamental elements and formation processes that govern celestial bodies across the vast expanse of the universe. By meticulously scrutinizing the composition and structure of Oumuamua, researchers embarked on a quest to unravel essential clues about its origins, the challenges it faced during its interstellar journey, and the dynamic processes that shaped its unique attributes. The revelations they uncovered were truly astonishing. Through extensive studies, scientists pieced together a comprehensive picture of Oumuamua's composition and characteristics. These findings weren't just a mere glimpse into a solitary object. Instead, they became a treasure trove of knowledge, offering insights into the conditions and phenomena that influence distant interstellar entities. Each nugget of data extracted from Oumuamua's examination served as a stepping stone, guiding scientists towards a deeper comprehension of the forces governing celestial bodies as they traverse the vast expanses of the cosmos. How Pan-STARRS 1 revealed Oumuamua's secrets. Oumuamua's appearance as a long, rocky object shaped like a cigar is very different from the usual asteroids or comets we see in our solar system. Comets usually come from far out in our solar system, like the Kuiper Belt or the Oort cloud. They're made of frozen gases, water ice, dust, and rocks. But Oumuamua stands out with its unusual elongated shape, which is unlike the more round or uneven shapes we see in most comets. These comets often look like dirty snowballs, with various bumps and textures. When comets get close to the sun, the ice inside them starts to turn into gas and dust, making a cloud around the core. Sometimes this forms a tail that points away from the sun because of solar wind and radiation pressure. Comet nuclei come in different sizes, ranging from a few hundred meters to several kilometers across. Halley's Comet, one of the famous ones that come by every so often, has a core estimated to be about 15 kilometers across. While some comets have even bigger cores, they usually have a similar shape and structure. Oumuamua is also different because of its reddish color, which is not typical for regular comets. This color is more like what we see in objects way out in the solar system, hinting at something unique about its makeup or surface. What's interesting is that, despite being close to the sun during its trip, Oumuamua didn't have the usual cloud of gas and dust around it, something common in regular comets. This absence showed that Oumuamua wasn't a typical comet at all, but something completely different. Oumuamua is quite the light show as it twirls around, changing how bright it looks by a whopping factor of 10. It takes about 7.3 hours for one full spin, and this wild change in brightness is way more extreme than anything we've seen with asteroids or comets in our solar system. This crazy feature highlights just how unique Oumuamua is, but figuring out how big it is, well, that's where things get tricky. Different studies and observations have come up with all sorts of guesses about Oumuamua's size, making it pretty confusing to nail down its real dimensions. NASA's Jet Propulsion Laboratory took a shot at it and suggested Oumuamua might be anywhere from around 320 feet to a maximum of 1,440 feet across, if it were a round shape within that size range. On the flip side, NASA's Solar System Exploration Team thinks Oumuamua is more like a quarter of a mile long, which is around 10 times longer than it is wide. That's a huge difference and suggests it's super stretched out along its main axis, unlike anything we've seen before. But then, a newer study disagrees with these earlier guesses and thinks Oumuamua is way smaller, around 146 feet by 144 feet by 24 feet. That's significantly tinier than what was thought before. But even with all these different guesses, one thing stays the same: Oumuamua's cigar-like shape. Figuring out what it is will need some serious studying, and the Pan-STARRS. One telescope is a big part of that. It's a crucial tool for checking out Oumuamua and other stuff flying around in space. The Pan-STARRS. One telescope sits up near the top of Haleakala on Maui, Hawaii. It's got a 1.8-meter diameter and is a huge part of the Panoramic Survey Telescope and Rapid Response System project. This big project involves a bunch of groups like the University of Hawaii Institute for Astronomy, MIT Lincoln Laboratory, Maui High Performance Computing Center, and Science Applications International Corporation. They use this telescope to scan the sky all the time, using cameras, scopes, and a supercomputer. It doesn't just find moving or changing things in space, it also gives precise details about stuff we already know about. Since it officially started looking at space on May 2010, the Pan-STARRS. One telescope has done a lot. One of its big achievements was spotting Oumuamua. This telescope is special because it's built to study things like Oumuamua. It's got a unique design that lets it look at a huge part of the sky when it watches, making it way more likely to find things that are very faint and hard to spot. It's got a big field of view that covers about 7 square degrees and uses a massive 1.4 gigapixel camera. That means it gathers tons of info and is good at finding and keeping track of things in space, even if they're not very bright. Plus, being in Hawaii gives the Pan-STARRS 1 telescope some great advantages for studying things like Oumuamua. The island has really clear, dark skies, so there's not a lot of extra light to mess up the observations. When you combine that with the telescope's ability to see faint things, it becomes good at spotting objects like Oumuamua. Speaking of which, Oumuamua came into our solar system from a place near the constellation Lyra, but we're not exactly sure where it came from. It might have been traveling through space for billions of years, drifting through the galaxy before it bumped into our solar system. Clues to alien civilizations and interstellar travel. A groundbreaking study in nature astronomy put forth a fascinating idea about where Oumuamua might come from. It suggests that Oumuamua was probably once a part of a bigger planet in another solar system, but that planet was close to its star and got torn apart by the strong gravity there. So, bits of it were scattered out into space, and that's how Oumuamua began its journey between stars after getting kicked out of its original home. One of the weirdest things about Oumuamua's trip through our solar system is how it unexpectedly sped up. It suddenly got faster, which made it go a bit off its expected path. When it first came into our solar system, it flew pretty close to the sun, just about 0.25 astronomical units away. After that close pass, it kept going, but dipped below the plane where the planets orbit. While it traveled through our solar system, it zoomed at an incredible speed of around 196,000 miles per hour. That's super fast and shows that Oumuamua had a lot of energy from the get-go. But why was it so fast? Scientists think it might have to do with what it's made of. Studies suggest that Oumuamua has a tough outer layer made of carbon-rich stuff that got hardened over a long time by cosmic radiation during its super long trip between stars. Inside, it's dense with lots of rock and maybe even some metals. But here's the kicker. There's no water or ice inside it. That's pretty different from regular comets or icy things we find in our solar system. Also, its surface has this reddish color because it's been bombarded by cosmic rays for millions of years. That's made a lasting change to how it looks, setting it apart from other similar objects out there. The idea that Oumuamua might be something created by an alien civilization is gaining attention, stirring up some pretty wild thoughts among experts. They're looking at things about Oumuamua that just don't fit with what we usually see in space. For starters, its shape is seriously odd. It's not round or bumpy like most things out there. Instead, it's long and cigar-shaped, which is unusual for stuff flying through space. What got people thinking is how it moved. Its path didn't match up with what we'd expect from gravity alone. Some think it might have been pushed along by some kind of weird technology. Maybe a super advanced solar-powered sail or some other engine we haven't even dreamed up yet. This way of thinking leads to a mind-boggling idea. Maybe Oumuamua is just a piece of a spaceship, or some gear sent out on a purposeful trip by aliens wanting to explore other stars. And here's another thing that got folks scratching their heads. Oumuamua didn't have the Taylor gas that usually trails behind comets or asteroids. Some say that's on purpose, maybe to keep it hidden. They think these maybe aliens might have some kind of secret way to move through space that we don't know about yet. That reddish color on its surface? Some think it could be a choice made by these potential alien creators. They might have used special materials that react to space radiation, giving Oumuamua that unique color. It could be a way to blend in with other reddish objects out in space, maybe to avoid standing out too much. But why would an alien-made thing want to hide while it travels through space and visits other star systems? Picture this: an alien civilization in a faraway star system with top-notch tech that lets them explore the universe and check out other civilizations. They spot Earth and see signs of life, making them curious about our planet and all the different life here. Captivated by the mystery, they opt to launch a reconnaissance mission, seeking to unravel the enigma. Enter Oumuamua, the peculiar celestial entity that, in this narrative, could be perceived as a craft crafted by an extraterrestrial civilization. Its distinctive form and composition might have been engineered for safe passage across interstellar distances. The elongated structure likely serves as a shield against cosmic debris, ensuring stability during its extensive journey through the cosmos. What renders Oumuamua truly extraordinary isn't solely its shape, but its method of locomotion. It appears to possess an advanced mode of propulsion, granting it the ability to traverse great cosmic distances with precision. This extraordinary mobility enables it to explore freely and navigate through obstacles with agility. Oumuamua is equipped with sophisticated technology, boasting state-of-the-art sensors and advanced communication devices. Its primary objective seems to involve clandestine reconnaissance of Earth, gathering intricate details about our atmosphere, terrain, and any indications of intelligent life. Once it compiles this data, it transmits it back to its creators, offering them invaluable insights into our planet from afar. The peculiar maneuvers of Oumuamua, initially approaching Earth, then abruptly altering its course, could fit into a narrative. Perhaps it concluded its mission and departed swiftly from our solar system, a swift departure aligning with the notion of fulfilling its objectives and departing. Oumuamua's divergence from known cosmic phenomena hints at realms of knowledge yet uncharted. Verifying or disproving this intriguing hypothesis poses a formidable challenge. Oumuamua's uniqueness presents an obstacle, as our existing tools and observations are insufficient to fully decipher its nature. Strategies for probing a distant celestial enigma. Delving into Oumuamua's secrets presents a formidable task, demanding meticulous planning and precise execution. To embark on a mission dedicated to studying this enigmatic object, scientists must aim to develop and launch a spacecraft by the year 2028. This specialized spacecraft would need to withstand the harsh conditions of interstellar space and carry state-of-the-art instruments capable of scrutinizing Oumuamua's composition, shape, and behavioral patterns with great precision. Once launched, the spacecraft faces the daunting challenge of intercepting Oumuamua, requiring complex maneuvers. One proposed strategy involves harnessing Jupiter's gravitational pull to propel the spacecraft forward, significantly reducing travel time. Estimates indicate a journey of approximately 26 years for the spacecraft to rendezvous with Oumuamua, contingent upon its speed and trajectory. Alternatively, scientists have suggested an alternate trajectory utilizing the gravitational forces of Venus, Earth, and Jupiter. By intricately aligning the spacecraft's path with these celestial bodies, a similar time frame could be achieved while mitigating risks associated with proximity to the Sun during the voyage. This path would involve around 4 years of utilizing gravity assists from Earth, Venus, and Jupiter, facilitating trajectory adjustments and aiming for a rendezvous with Oumuamua between 2050 and 2054. Upon reaching Oumuamua, the spacecraft would enter a critical phase of scientific investigation. Equipped with advanced instruments, it would meticulously analyze the object's composition, shedding light on its origin, makeup, and inherent characteristics. Detailed observations of Oumuamua's shape and behavior aim to decode its mysteries and extract valuable data. However, communication poses a significant hurdle due to Oumuamua's vast distance from Earth. The spacecraft would require an advanced communication system, possibly leveraging cutting-edge technologies or a network of relay stations. One potential option involves using NASA's Deep Space Network, equipped with specialized antennas for long-range communication. This network's high-powered transmitters and sensitive receivers would capture the spacecraft's signals and relay crucial information back to Earth. Exploring alternatives like laser communication systems, employing highly focused laser beams for enhanced data transmission rates, emerges as an intriguing prospect compared to traditional radio wave communication. Looking forward, an ambitious idea with great potential is the creation of an interstellar internet, a network of strategically positioned relay stations intended to facilitate data transmission from spacecraft to Earth. Similar to how data moves between nodes on the internet, this interstellar network would require significant advancements in communication technology and infrastructure. To tackle the immense communication challenges posed by vast interstellar distances, spacecraft would need highly advanced transmitters and receivers capable of handling such extraordinary spans. These systems would utilize cutting-edge modulation and coding techniques to optimize data transmission while counteracting signal degradation effects. One potential avenue for enhancing communication during missions aimed at studying Oumuamua might involve collaboration with initiatives like Elon Musk's Starlink. Starlink's objective is to establish an extensive satellite network in low Earth orbit, providing global broadband coverage. Leveraging the Starlink constellation, composed of thousands of satellites, could significantly bolster communication capabilities for deep space missions. Integrating such initiatives could revolutionize our ability to communicate with spacecraft venturing into the far reaches of our solar system and beyond. Outfitting the spacecraft dispatched to explore Oumuamua with a communication system compatible with Starlink's network could revolutionize data transmission to Earth, potentially broadening coverage and speeding up data transfer rates. This collaboration could significantly benefit the scientific observations and analysis of Oumuamua. However, integrating such an alliance would demand meticulous coordination among space agencies, private companies like SpaceX, and the scientific community. Technical details such as aligning communication protocols, adapting spacecraft equipment, and synchronizing orbits would be critical considerations. While NASA has ongoing collaborations with SpaceX, expanding this cooperation to scientific endeavors might be a feasible extension. Yet even if communication hurdles are surmounted, numerous other critical factors loom large. The intricacies inherent in ensuring the success of a mission dedicated to studying Oumuamua, spanning spacecraft design, propulsion, navigation, data collection, and analysis, underscore the multifaceted nature of such ambitious ventures. Each facet necessitates thorough planning, rigorous testing, and inventive solutions to overcome the challenges of interstellar exploration. Tackling these complexities demands a fusion of expertise, technological ingenuity, and collaborative efforts among diverse stakeholders. As humanity strives to unravel the mysteries surrounding distant celestial objects like Oumuamua, each forward stride necessitates comprehensive planning, unwavering commitment, and a readiness to push the boundaries of our cosmic comprehension. Now it's time for today's subscriber pick. Lately, there's been a buzz around Oumuamua, capturing the interest of both scientists and enthusiasts. Joe Rogan, a well-known media personality in the US in one of his podcasts, revealed that Oumuamua suddenly showed up again and is sending signals to Earth. Some have suggested it could be from aliens, which has gained attention partly due to acknowledgments from the Pentagon's UFO office. Some researchers, like Sean Michael Kirkpatrick and Harvard professor Avi Loeb, believe Oumuamua might be an alien-made spacecraft. But this idea faces criticism from scientists who argue that the huge distances in space make interstellar travel unlikely. Also, the absence of detectable signals from Oumuamua raises doubts. Despite the uncertainty, Joe Rogan, known for his questioning mind, considers deeper meanings behind Oumuamua. He wonders if it's a message pushing humanity to explore more or a test to gauge our technological advancement. Rogan stresses that space exploration encourages innovation and attracts funding from visionary billionaires. However, if Oumuamua is an alien spaceship, its incredible speed hints at the potential for a rapid Earth arrival, possibly resulting in catastrophic consequences like widespread destruction. It opens up the uncertain territory of facing an alien invasion with unforeseen impacts. While speculative, these possibilities can't be entirely dismissed, especially when credible scientists consider Oumuamua's extraterrestrial origin. Alternatively, if it's just a space rock, the concern would be dealing with the aftermath of a collision. Let us know your thoughts in the comments below. Charting a course to study Oumuamua's secrets. Studying an extraordinary object like Oumuamua presents an unparalleled opportunity for scientific exploration, but it's far from straightforward. There's a host of technical challenges that demand inventive solutions. Interstellar objects, like Oumuamua, require state-of-the-art instruments capable of enduring the harsh conditions of space. Engineers and scientists must design equipment that functions flawlessly in the extreme cold and constant radiation of interstellar space. This doesn't just require innovation. It needs extensive testing to ensure the spacecraft's reliability and the functionality of its instruments. Exploring the unknown carries inherent risks. Oumuamua's exact nature and composition remain a mystery. This uncertainty brings the potential for unexpected dangers during the mission. From encounters with hazardous materials to exposure to high radiation or the impact of tiny space debris, experts must thoroughly assess these risks and devise solid plans to protect the spacecraft and ensure mission safety. Navigating and controlling the spacecraft's path to intercept Oumuamua is also highly challenging. It demands precise navigation and complex maneuvers. Matching Oumuamua's path and making necessary course adjustments require pinpoint accuracy. Even a small miscalculation could mean missed opportunities or collision risks. Success hinges on accurate trajectory calculations and reliable propulsion systems, both crucial for a successful mission. As much as we wish otherwise, resources are a significant concern. Launching a mission of this scale requires substantial financial investment and cutting-edge technology. Balancing these constraints while aiming for a successful mission adds another layer of complexity to the endeavor. Securing sufficient funding and backing from space agencies and governments faces considerable hurdles, given the multitude of priorities in the realm of space exploration. Overcoming these challenges requires meticulous strategic planning, fostering partnerships, and ensuring effective coordination among various stakeholders. This, however, proves to be a formidable task, particularly amid the diverse and pressing demands on Earth that vie for the same financial support. Yet, this shouldn't be seen as a deterrent to our pursuit of unraveling the mysteries surrounding this captivating object. There are viable actions we can take right here on Earth at this very moment. One avenue involves maximizing the use of telescopes and instruments to observe Oumuamua. Despite its transient visibility, astronomers successfully captured valuable data during its transit through our solar system. These observations provided initial insights, and now, armed with the compiled information, scientists globally can collaborate to extract further knowledge. By pooling their expertise and delving into the existing data reservoir, they have the opportunity to unearth more mysteries surrounding Oumuamua. This collaborative approach allows scientists to tap into the wealth of information already available, avoiding the complexities of an interstellar mission laden with challenges. It maximizes our current resources and knowledge, offering a promising avenue to deepen our understanding of this enigmatic visitor from beyond our solar system. A glimpse into future interstellar object investigations. Determining the path that Oumuamua follows has been important in figuring out where it came from and where it might be going. By figuring out its trajectory, scientists have gotten a sneak peek into the journey this object has taken through space, shining a light on the part of space it probably came from. Even if we don't have a lot of direct information about Oumuamua, figuring out its orbit is a big deal because it helps us understand how objects from outside our solar system move around and interact with our solar system. This is an accomplishment on its own. Computer simulations are a crucial part of studying Oumuamua. Scientists create virtual models using the data they have, and this helps them explore different possibilities and test ideas about what Oumuamua is made of, how it behaves, and where it likely came from. These simulations are a key tool in improving our understanding of Oumuamua's characteristics and the complex processes that govern its journey through interstellar space. Another way scientists investigate Oumuamua is by looking at its chemical makeup. They study its spectral signatures and analyze its chemicals to learn more about what elements it's made of. This kind of examination can reveal important clues about how Oumuamua formed and what it's like at its core. Recent studies suggest that Oumuamua might come from a comet made mostly of nitrogen ice, showing how chemical analysis plays a crucial role in unraveling its mysteries. Comparing Oumuamua to other objects in our solar system and beyond has been extremely useful. By looking at how it's similar or different from things we already know about, scientists can gain important context and insights into what makes Oumuamua unique. These comparisons help broaden our understanding of the different kinds of celestial objects out there. Looking ahead, there are exciting opportunities for studying more interstellar objects. Future projects like the Large Synoptic Survey Telescope and the Vera C. Rubin Observatory are ready to change the game in terms of our ability to find and explore these cosmic travelers. The LSST holds a lot of promise for a groundbreaking discovery. It's estimated to spot more than 100 interstellar objects larger than 2 meters every year. This flood of new objects will give us tons of fresh things to study in detail, really pushing our knowledge in this area forward. The Vera C. Rubin Observatory, known for its thorough and organized scans of the sky, is going to be a big player in helping us understand cosmic events, including visitors from other star systems. Its broad approach lines up perfectly with studying things like Oumuamua, while the pan-stars. One telescope has been a big help in this field. The combined efforts and extra tools from upcoming observatories like LSST and the Vera C. Rubin Observatory look set to take our exploration of these interstellar objects to the next level. The Hubble Space Telescope is an amazing observatory run jointly by NASA and ESA. Its super-detailed imaging has been crucial in examining Oumuamua. Through really close-up pictures, Hubble has given us valuable details about the object's shape, surface, and color. These specifics are incredibly important and could be key pieces in figuring out more about this mysterious visitor. Back here on Earth, the Very Large Telescope in Chile, operated by the European Southern Observatory, has also been important in watching Oumuamua. With fancy tools like the focal reducer and low-dispersion spectrograph, the VLT has done tests to figure out what Oumuamua is made of and maybe find out what makes it unique. Also in Chile, the Atacama Large Millimeter Sub-Millimeter Array has added to what we've seen with optical telescopes by looking at Oumuamua in longer wavelengths. ALMA's radio telescopes have given us important data, like clues about gas coming from the object, giving us more hints about what it's like. As Oumuamua passed through our solar system, the James Webb Space Telescope stands as a beacon of hope for future studies of this interstellar traveler. With its cutting-edge tools and heightened sensitivity, the JWST could bring forth fresh observations and uncover intriguing details about similar cosmic visitors. This telescope holds the potential to enhance our understanding, ensuring that if Oumuamua were to swing by again, or if another similar object were to journey through space, we'd have the right tools to delve deep into their secrets. Being ready is crucial. If another similar interstellar object surprises us, the combined efforts of various observatories and technologies like the JWST make sure we have a comprehensive approach to unlocking the mysteries of these cosmic wanderers. But there's still the big question: can we ever really figure out what's going on inside Oumuamua? The challenge with interstellar objects is that they're often fleeting and mysterious, and we don't have a lot of data about them. Despite all the fancy tools and telescopes we have, the inner workings of Oumuamua might just stay hidden. Thanks for watching, and we'll see you in the next one.